So now it's time to take things a step further and move on to infinite geometric series. Now an infinite geometric series is just a geometric series that goes on forever. It has no end. So over here, you can see we have an infinite geometric series that goes 1 over 2 plus 1 over 4 plus 1 over 8 plus ... to infinity and beyond. And the big question is, what does this series evaluate to? Now, most students, when they're first presented with this problem, they have trouble deciding. Could this series evaluate to some finite and defined value? Or is the answer just infinity? Because if we keep adding terms, the result is just going to get bigger and bigger. So surely the sum is just going to be infinity, right? Well, I can tell you one of those answers is indeed correct. Which one? Well, you're just going to have to stick around and find out. So let's do it together. Now to tackle this infinite geometric series, we're actually going to be using a strategy that we used before when we were dealing with finite geometric series. It's going to be the exact same thing. And we started off by calling the entire series S. So from now on, whenever I say S, we are referring to this infinite geometric series. Our next step was to multiply S by the common ratio to get a new series. And here the common ratio is 1 over 2. So if we multiply S by 1 over 2, we're actually going to get a completely new series that goes like this. Now it's going to start at 1 over 4, 1 over 8, and it just goes on and on. And from here, we're going to subtract the two series to get half S equals 1 over 2 plus 0, 0, 0, 0, 0. You get the idea. Now from here, all we need to do is find S. Well, luckily for us, S is just 1. So this infinite geometric series does indeed evaluate to a value. It evaluates to 1. So now we have another infinite geometric series that goes 5 plus 5 over 3 plus 5 over 9 plus 5 over 27, and it just continues. So what does this equal to? Now we're going to be doing the exact same thing that we've been doing all along. We're going to multiply this series by the common ratio to get a new series, and then we're going to subtract the two. So we're going to start off by calling this whole series T. Today it's going to be a little different. I got a little bored with S, so we're going to be doing T. Now the common ratio of this series happens to be 1 over 3. We multiply 5 by 1 over 3 to get 5 over 3. We multiply 5 over 3 by 1 over 3 to get 5 over 9. We multiply 5 over 9 by 1 over 3, we get 5 over 27, and it just continues. So since the common ratio is 1 over 3, our new series is going to be 1/3 T. Because when we do that, we get a new series that looks like this. Starts with 5 over 3. We get 5 over 9, 5 over 27. and it just continues. And now we can take these two series and subtract them. Because once again, when we do this, t minus 1 over 3t, that's just 2 over 3t. And this equals 5, since everything in the middle just vanishes. And since we want to find t, we can find t by multiplying both sides by 3 over 2 to get t equals 15 over 2.